So what I want to do is talk about data mastering or data integration, if you'd like to call it that. So first of all, I'll just briefly say what it is so we all get on the same page. And then I'll talk about what does it mean if you have to do data mastering at scale. And at scale, I'll then tell you why all the traditional solutions fail. And then I will move on to what you've got to do to solve data mastering problems at scale. And I've got to find my cursor so I can advance the slides. Okay, so what's data mastering all about? Well, enterprises are full of what I call data silos. And why is that? Well, enterprises generally decompose themselves into independent business units, IBUs I'll call them. And the reason they do this is so that you can have business agility. Otherwise, all decisions have to go through God. An independent business unit, if it's in charge of selling widgets to the Eskimos, puts them in an independent data silo. So enterprises are full of data silos, one or more per business unit. And after the fact, there is huge business value in integrating such silos. Just for example, if you're the widget business unit and across the country there's the refrigerator business unit, if you are trying to sell to a new customer, you'd like to know if the refrigerator guys are already selling to that customer. So you'd like to integrate customers so that you can do cross-selling. Just one other example, if you are the widget guy and you are buying sub-widgets from a supplier, say Oracle, you'd like to know is anybody else buying sub-widgets from Oracle? Because if so, maybe they get a better price than you do and you want to just climb onto their price schedule. So get the best price across independent business units requires you to integrate suppliers. And so after the fact, there's huge business value in integrating silos. So what the general issue is that after the fact, if you only have one business unit, then of course there's only one silo. And as you create additional silos, often because you're buying other companies which come with their own silos, or you're starting up new businesses and you tell them to be agile, get going, get a product out, you create silos. And after the fact, you want to integrate these independently constructed data sets for these common entities, customers, suppliers, parts, and so forth. Now, I'd like you to tattoo this on your brain. Independently constructed schemas for these data sets are never plug compatible. I have never seen independently constructed schemas be plug compatible. It just doesn't happen. Why doesn't it happen? Well, I'll just talk briefly about what does integrating data silos entail. Well, first of all, you've got to move data sets to a common place, load them into your data warehouse. That's sort of the 90s way of thinking about things. Move stuff to a data lake. That's sort of a common thing a few years ago. Move them to the cloud. Move your data sets to a common place. So if you're the human resources person in Paris, I'm the human resources person in New York. You have employees, I have employees. You have salaries, I have salaries. However, your salaries are in euros, mine are in dollars. So you've got to perform transformations to get data into common units. Moreover, if you're the Europe HR person, your salaries are net after taxes and include a lunch allowance. In New York, mine are gross before taxes, no lunch allowance. So you got to perform transformations to get these data items into common units and have common semantics. So once you've done that, then you've got to line up the various columns that mean the same thing. You call them wages, I call them salaries. That's called schema integration. And then now you're ready to try and put this stuff together. One thing that is just invariably true is that 10% or so of your data is dirty, missing, or wrong. For example, some people who are using systems that don't have built-in support for null will tag some specific value as null. So 99 often means, minus 99 often means null. If it's a salary, for goodness sakes, don't try and put together salaries that include these coded values for null. So you got to do data cleaning. As often as not, you'd like to enrich the data with other attributes to make the steps I'm about to talk about easier. So perform data enrichment, which is to do joins with other data sets that may give you additional attributes. And then comes the heavy lifting. If I'm Mike Stonebraker in one data set, I'm MR Stonebraker in the second one, and I'm Michael Stonebraker, spelled wrong, in the third data set. I've got duplicate entities. That's the whole idea, is to find common suppliers, common customers, and so forth. So I've got to consolidate duplicates. So that's called entity consolidation. So I want to find all the records in all the data sets that mean the same thing. I want to find all Mike Stonebreakers. Once I've found a cluster of records that I think are duplicates, then I've got to find what are called golden records. So, for example, I only have one legal age. There may be multiple records with multiple ages, and I want to consolidate them into my best guess of what the real age actually is. And you could take the most frequent value, you could have trust parameters, and so forth. So you want to find golden values for clusters of records to consolidate a collection of duplicates down to a single golden record. As often as not, you also want to perform classification. If you're looking for suppliers, you might want to classify them as either international or local, and then do all of this on an ongoing basis as data sets are added, subtracted, as the data gets updated, as the needs of your customers change, and so forth. So that's what silo integration is all about. It never just works. You have to perform a pipeline of some number of these actions in some order, and this is what data mastering means. Now, some people call it master data management. Some people call it data integration. Some people call it data unification. Some people call it data ... So we'll just use data mastering to mean this stuff. All the words on this slide mean the same thing to me. Okay, so that's what data mastering is about, and it's a really important issue to tackle in sizable enterprises. So in this talk, I will worry about three components of this pipeline, only because I don't have an unlimited amount of time. So I will talk about schema integration, which is lining up the columns. I'll talk about entity consolidation, which is find all the duplicates for Mike Stonebraker and consolidate them down into a golden record. And I'll talk about classification. Suppliers are international or local. So that's what's coming in the rest of the talk. So what does it mean if you want to do data mastering at scale? So that means hundreds of entities, millions of records, hundreds or thousands of data sets. Do this at large values for all the things that you are concerned about. Okay, so let me just give you a few examples of dealing with scale. So I'll talk about schema integration first. So what does schema integration at scale mean? Well, GlaxoSmithKline, GSK, happens to be a Tamer customer. They're using Tamer to help them do schema integration. Their aspiration is to master research data worldwide. What that means is they have thousands of data scientists who are typically doing wet stuff in the lab, writing down research results, think of them in electronic lab notebooks, and GSK wants to find people who are producing the same gook using different reagents, find people who are using the same reagents to produce different gook. So they want to be able to do social networking among a large number of scientists and also add in all the public data off of the web. They say that their schema integration problem has more than 10 million column names. So do schema integration at scale 10 million going on 100 million. Second example of data mastering at scale, I'll do one with entity consolidation, also a Tamer customer. And this is Toyota Motor Europe. That is the Toyota organization that sells and maintains Toyota cars in Europe. Now, right now, what happens is that if you buy a Toyota in Spain, well, you get it serviced at your local Madrid dealership. And then, as you know, in the EU, you can move to France. So you drive your Toyota to France, and then you want to get it serviced in Paris. Well, the Paris guys know nothing about the Spain guys, because it turns out Toyota does distribution at a country level basis. Sometimes at a smaller granularity, they do it at a canton level in Germany. So they want to avoid customer amnesia on relocation. Obviously, when I move to France, I want the records of my maintenance to be visible to the France guys. So they want to master customers across all of Europe. That is more than 30 million customers. Turns out that's in 250 plus databases. Most of these databases are run by dealers and service centers who don't officially report to global Toyota. So Toyota has limited control over what the actual attributes are that are in these various data sets. And by the way, these databases are in 40 languages. So do customer mastering at scale, meaning 30 plus million customers in 40 languages. Let me just do one other entity consolidation for you, because I'm going to use this example later on. An unnamed media company whose name I can't tell you, they are in the business of creating and then licensing content. So think of these as songs, think of these as movies, think of these as, whatever, so content. So they receive requests for licensing, and they receive royalties on content from all kinds of places. So they got to put together all this stuff. And they want to deduplicate it because one customer may think of it as Star Wars, another one may say it's the Luke Skywalker film. So take 7.8 million records, which is how many they've got, and do entity consolidation to produce 1.5 million golden records. So do this again at scale millions. Last one that I'll talk about is classification. GE, their CFO wants to classify spend transactions into a pre-existing classification hierarchy. So the hierarchy is everything they spend money on. So they spend money on office supplies. A sub category of office supplies is, paper, printer paper, and so forth. So CFO wants to understand where the money goes and wants to classify spend transactions into that classification hierarchy. And he wants to do 20 million of them, which is, I'm not sure what the time period is, but they asked Tamer to help them classify 20 million transactions. Okay. So that's what scale means, which is do this at scale millions. So why do the traditional solutions fail? So the traditional solutions come to you from the companies I like to call the elephants, who are in the data integration business, people like IBM, people like Informatica, people like Talent, people like Naime, those guys. So most of them have schema integration products, and the standard wisdom is that you put table 1 up on the left-hand side of the screen, you put table 2 up on the right-hand side of the screen, and you start drawing lines between matching attributes. So salary is on the left-hand side, wages are on the right-hand side. Draw a line between them to indicate those are the same attribute. So that works great if you got 2 tables and 25 attributes. However, imagine this for GSK's problem, which is 10 million attributes. You will get carpal tunnel syndrome for sure, drawing all these lines, and it will take absolutely forever. So any solution that requires a human to make connections will fail at scale. So traditional solutions for schema integration do not scale. Okay, what's with entity consolidation? Well, the traditional solution available from the elephants, they often call this match merge. Entity consolidation means find the records for the matching entities and then merge them into a golden record. So if you're familiar with the term match merge, it's the same stuff. So the elephants say, well, write some rules. And one rule might be that if you're the content company, if the edit distance between names of content items is less than some magic threshold, then they're the same thing. That would be a way to do matching. Merging is take the most frequent value when merging, for example, to produce golden records. So these are examples of rules designed to help you do what they call match merge. Okay, so now let's go back to this media company, which is using a homebrew version of such a system. So to consolidate 200,000, to consolidate 7.8 million records, they wrote 200,000 rules. And I just want to stop and highlight that's 200,000. In a homebrew rule system, which is their internal code, they have been at this for 2 people times 13 years, 26 person years. And imagine a cost, this is millions of dollars. And they are dug in really deep. The system is completely unmaintainable. It takes forever to add a new data source, takes forever to change data source names or change anything. So content gets renamed, and this is horrible. So they are dug in really bad, and they've written 200,000 rules. And any of you who've ever written rules can just imagine that 200,000 rules is a nightmare. So what's wrong? What's wrong with lots of rules? We'll just quickly do a classification example because that has some data attached to it. Classify any transaction from staples as office supplies. That would be a rule that would help you do classification, which is you're trying to decide spend transactions into a classification hierarchy, write a bunch of rules. Now, the general wisdom that people who do this stuff day in, day out is that you can grok about 500 rules. So you can get your brain around about 500 rules. Twist my arm hard and I'll give you 1,000. I will never give you 200,000. So the general wisdom is that a few rules is fine. Hundreds of rules, well, yeah, you can do that. Thousands of rules, forget it. Because there's an exponential cost in grokking additional rules, and you get into the nightmare that the media company is currently experiencing. So rule systems do not scale. The reason is that a human has to be able to understand the global scope of these rules, and a human can understand hundreds, not thousands of such rules. So what happened to GE? GE took the advice of the elephants and they wrote 500 rules in a rule notation. What did that do? That classified 2 million out of their 20 million transactions. So they got 10%. So what do you do with the other 18 million? Well, classifying 2 million, isn't helpful. That's 10% of your problem. So they realized very quickly that to continue doing a rule system to get to 20 million, they would have to write at least 5,000 rules and probably more like 50,000 rules. And they realized immediately that this wasn't going to scale. This was going to give them the nightmare experienced by the media company. So they closed down that whole endeavor because it just wouldn't scale to the size of problem they had to solve. So I've gone through 3 examples of why the elephants don't scale. Schema integration doesn't scale because it has too much human involvement drawing these lines. Entity consolidation and classification don't scale because they're fundamentally based on rule systems, and rule systems don't scale to the size of problems these folks want to solve. So what do? The only game in town is you've got to invoke machine learning. You cannot do this with a rule system. So what is ML all about? Well, assume you have a task at hand. Say you're GE and you want to classify 20 million spend transactions into their pre-existing classification hierarchy. So the desired outcome is for every spend record, 20 million of them, they want to produce a classification bucket, which is where this spend transaction should be classified. So classification for every record, do it times 20 million. Okay. So to invoke ML to help you, that requires you to get some training data, which is you get some example records that are where you know what the classification is. So you get a Mike Stonebraker spent $20 on a taxi to Logan Airport, and the training data says, well, that should be classified as the subcategory of travel, and underneath that, taxis. So you have some training data, and you use that training data, which is example output, to fit a machine learning model and the model then predicts the desired value for the rest of the data. So that's what ML is all about. Get some training data, which is exemplar output, and then use that training data to fit an ML model, which predicts the value for the rest of the data. Now, usually you want to do this with active learning, which is if you notice a misclassification, you then have a human fix that mistake, and that becomes more training data, so the whole thing becomes iterative. So that's what ML is all about, stripped away down to its simple essence. So training data is required. You cannot do it without training data. So how do you get training data? Well, first of all, if you are lucky, you have some training data lying around from some previous effort. So if that's true, God is on your side, you're home free. If you don't have training data, you've got to get some. Now, it's a non-starter to generate this manually. At scale, getting training data by having a human do data entry one by one won't scale. Well, you might say, well, why don't I just get hundreds of folks from Iowa to use Mechanical Turk to just do this in parallel with low-cost labor. Well, this isn't going to work because GE's classification system, requires, is a skilled task that requires you to understand a lot. So you cannot delegate this to unskilled personnel. You've got to have people who know what they're. So anyway, I was in the middle of telling you had to have to get training data. So where does training data come from? If you construct it manually, hell will freeze over before you get enough of it at scale. So you've got to use rules to create training data, or some mechanism to create a bunch of it without it taking forever. But you said, well, you did this, you were downplaying rule systems. I have no problem with rule systems as long as you only have to write 500 of them. So write 500 rules, as in the traditional approach, and that gets you some training data. That's not all the data, that's just a small subset. And look at your training data, correct it if it's got errors and so forth. So get some training data, and I have no problem with using rules. God is on your side if you've already got some or have some other way to get it. So GE did exactly this with Tamer's help. They used the 2 million records from their 500 rules, and they used that as training data. They fit an ML model, which classified the remaining 18 million records. Worked like a charm. So use machine learning. That's the only thing that's going to work at scale. Okay, now machine learning isn't trivial. And at scale, it's really not trivial. So let me just talk about a few of these issues. Skew in the training data, which is if your training data isn't representative of the data set as a whole, if your 2 million records are not representative of the 20 million records, then you will have an ML model that will be skewed and will produce poor results. If you have errors in the training data, then they will tend to make the results noisy. And you're about to tell me errors in the data, there's no such thing as perfect data. There are always errors, yes, all true, but you've got to get the data sufficiently clean so that it produces decent results. And then, of course, there's ongoing stewardship. There are new data sources to add, new humans to deal with who may have different needs. you're going to get feedback from bunches of experts who may not necessarily agree. So expert one claims that Staples is in office supplies. Expert two claims that Staples is in business solutions. So all of this makes this non-trivial at scale. And so lots of people write a little pilot. You can write a pilot using one of the traditional vendors, using rule engines or whatever. And scaling this up is going to fail if you're using a traditional vendor. Even if you're using ML, scaling up is not as easy as it might seem. So be prepared to put your best people on this project. Now, the other thing to really make note of is that scale, what algorithm you're using makes a huge difference. So if we're back to GlaxoSmithKline, who wants to do schema integration at scale, so they could build up a training set of pairs of matching attributes, then use ML to do the rest of their 10 plus million attributes. So they could do what I just talked about as the way to do apply ML. And basically, you're running an ML model to fit the training data to the rest of your problem. Okay, so far so good. That would be the obvious way to approach this. However, this isn't the only way. Alternative two would be to say, I've got, say, 1 million tables. I could turn this into a classification problem. So classify the tables into ones that are similar. So classify tables into like buckets. And then run ML on each bucket independently, assuming that if table 1 is in bucket 1 and table 2 is in bucket 2, then table 1 and table 2 do not have matching attributes. So that may or may not be true, but this would be another algorithm to deal with this problem, which is to turn it into a classification problem, then run ML on the classification buckets. So at scale, how hard these two approaches may be, and how much training your data you're going to need, and how accurate are the results going to be. At scale, this kind of algo stuff deserves careful thought. So at scale, ML is not going to be trivial. You've got to deal with skew, training data, humans, errors, and you've got to think about algo. But I guarantee you the traditional solution is not going to work at all. So it's either this way or the highway. And all I want to remind you is that this way works, but it isn't going to be trivial, and you've got to have people who know what they're doing executing this. Okay, so in summary, data mastering at small scale. If you've got 1,000 records in 3 tables and you want to do entity consolidation, do it manually, do it on your wristwatch, use one of the traditional solutions. They'll work just fine. And so at small scale, use whatever you want. Data mastering at large scale has to be done using machine learning, and is often, the devil is in the details. It's going to be an engineering challenge, and don't put neophytes on doing this. Get somebody who's done it before. Get some help from a vendor like Tamer, or make sure your people internally have done this before, because there are a whole bunch of engineering challenges and gotchas. Okay. Now, if your chosen solution provider, if you get help from, by the way, in this area, I would never recommend you build it from scratch. If you build it from scratch, chances are you're going to spend a lot of time on this, and you may well get into the quicksand that the media company got themselves into. If you are humongous, then you have a make versus buy solution, and you may well choose to make, but don't take on that lightly. So, get some expertise, often by getting a partner to help. And if your chosen partner's solution does not use ML, then just tattoo this on your brain. It is not going to scale. You are going to get into the quicksand the media company got themselves into when you try and scale up. But you might say, well, I only have a small problem. And yeah, that might be true right now, but chances are your CEO is going to buy somebody who may well turn this into a big problem. So chances are scale is in your future. And if your chosen solution provider doesn't use ML, and for schema integration, for entity consolidation, for classification, then you are going to be in quicksand sooner or later. And I almost guarantee you that your homebrew solution, if that's what you're currently using, is not going to scale. So the media company has a homebrew solution, and they are agonizing over what to do. So your chosen solution provider doesn't use ML. And by the way, all the traditional vendors that I know of, IBM, Informatica, NIME, those kind of folks, don't use ML for schema integration, for entity consolidation, or for classification. So they all tout ML, but they're touting it for something other than the bread and butter problem. So if your chosen solution provider does not use ML for schema integration, for entity consolidation, or for classification, then you're in deep trouble if and when you try and scale. So if you are in this situation, then come see Tamer. This is what we do. We apply ML to data mastering at scale. And if you don't have to do it at scale right now, then use anything you want. But chances are today's small problems turn into tomorrow's big problems. So I would plan on you having to solve mastering problems at scale. And the takeaway from this talk is the traditional vendors are simply not going to scale. So if you want to know more about Tamer, well, go to their website. And so this is a slide from our sponsor, who's one of the sponsors of this conference. And that's the end of my slides. I hope I've made some people mad and that there will be some questions.
Yes, sir, there are some questions.
I gotta stop sharing. So now I don't have to do anything else, do I?
Question, the first one that came in, anyone ever publish a confidence value next to the golden value? For example, I'm 80% confident that Mike is XX years old.
Tamer has confidence values associated with everything we do. ML fundamentally can do this. Traditional solutions fundamentally can't. So I think, yes, we do. Tamer does.
Okay. A comment, which may actually be a question. We tend to think that it's critical to provide consumers, that is systems and end users, with access to that info, even if doing so creates some challenges.
Well, what Tamer finds out is that customers have all sorts of policies in this area, and I think, this is a policy decision that should be made within each enterprise. I mean, I don't have global wisdom on how you ought to do this. All I can note is that essentially every Tamer customer has substantial politics in this area. The reason for that is that as often as not, there's a homebrew system. As often as not, there's a substantial group responsible for the care and feeding of that homebrew system, and they are against anything that would get rid of them, of course. And then, so as often as not, it's the business guys who want better stuff versus the techies, and I say that immediately devolves into politics. So I think, in general, I think absolutely, be completely transparent. I think that is the intellectually correct answer. But whether that's politically reasonable, I think, on a case-by-case basis, I've seen people do it both ways.
Well, you bring up a good point about the techies versus the business side. Do you help to knit those together when you go in, start working with a client?
Well, the first thing we typically, well, I would classify companies into two buckets: those that know what they're doing and those that don't. The ones that know what they're doing generally want the best solution for the least cost, which is what the business wants. The ones who don't know what they're doing are antagonistic toward new ideas. And, the first thing Tamer has to do is try and educate their techies about new ideas. Because often techies are stuck in the 1990s.
With their legacy systems.
Exactly. I think this rapidly gets into companies are full of legacy systems that if you could wave a magic wand, you would get rid of them. And management has the problem of deciding when and how to invest in new technology, because the new stuff does work better than the old stuff. And the unnamed media company is struggling with exactly that decision.
Right.
Which is when do they pull the plug on the old stuff? They know the old stuff is crap, but when do they pull the plug and decide to move forward?
Right. So there's a question related to that. Can ML be used on the systems that make the data?
Absolutely. I think the ideal thing for everybody to do is to, if the media company, the ideal thing for them to do is whenever they negotiate with a new consumer, don't just add that new consumer's data, incrementally put it into their classification system. In other words, fix the data problems at the source. Don't fix them after the fact. And moving to a system that does that in the long run will save mountains of money, because the person best able to fix data problems is the person entering the data. And so I think the further you can push these problems upstream, the better off you are. But the problem is silos are dug in pretty deep, and you can say, well, I can move forward with trying to dig out of these silos. Meanwhile, the enterprise is creating new ones, as we speak, when they buy new companies. So I think it's like whack-a-mole. You want to You want to whack down the stuff you know about, and that way you have a chance of dealing with the new stuff that comes in the door.
Mm-hmm. Let's see, when do programmers writing rules ever get access to production scale files? Rules are written to the accessible test data or small files.
Uh, but I mean, that's a management decision, and that will give you, unless your test data is representative of everything, that will be a recipe for disaster. Because I think if there's skew in the data that you have available, then your rule systems will produce crap. Your ML system will produce crap.
Okay. Question, are you going to provide a self-guided test drive for Tamer and prospective customers?
You'd have to contact Tamer.
Okay.
I mean, I don't know whether that's a great request. I don't know whether they do that or not.
Okay, and finally, any Informatica reps watching? How much of this is built in or planned for the Claire engine behind EDC?
That's not a question to me. That's a great question to ask your Informatica rep.
Okay.
As of Claire advertises that they do machine learning, but they don't do it for schema integration, they don't do it for entity consolidation, and they don't do it for classification. They do it for other stuff. So if you get any other answer from your Informatica rep, I would tend not to believe them.
Okay.
I mean, my favorite example is that I was asked many years ago, somebody told me, on what platform does Oracle run the best? And the answer was a 35 millimeter slide projector. And, the marketing guys for most large companies, are not particularly straight shooters.
Okay. All right. Well, we are going to wrap it up right here unless you have any closing thoughts you'd like to share.
I say I think the message is loud and clear. Ask the elephants when they're going to have this kind of stuff. Otherwise, come see Tamer.
Okay, great. Well, let's just hold here so Barry can close us out. Thank you very much.